Okay, now here is example 6. Okay, the question: determine the output voltage of the ideal op-amp differentiator in figure above. Okay, for the triangular wave input shown. Okay, dia ada bagi input waveform dalam triangular form. Okay, as you can see, this is a kind of differentiator. Okay, differentiator amplifier. Okay, and an ideal op-amp differentiator. Okay, di mana which is okay, dia ada capacitor pada input V in here. Okay, we have capacitor pada input. Ini dipanggil sebagai an ideal op-amp differentiator. Okay, dan this is the feedback from the output. Okay, this is the input waveform which is in triangular form. Okay, what is the difference between the op-amp differentiator dengan op-amp integrator? Okay, the difference is the circuit connection. Okay, where for differentiator, okay, the capacitor is put in the input side of the op-amp, whereas the integrator kind of op-amp, the capacitor is put on the feedback side from V out, and this is the capacitor. Okay, this is integrator. Okay, this kind of connection is the differentiator, and it is said that in this question it is an ideal op-amp differentiator. Okay, so the question is asking us to find the output voltage, okay, given the input triangular form. Okay, the higher peak is 5 volt and the lowest peak is negative 5 volts. Okay, we know the formula for differentiator. Okay, the op-amp differentiator is V out equals to negative VC over T times with R feedback times with C. Okay, so this is the formula for op-amp differentiator. Okay, okay, so for the positive going ramp, okay, for the start here, it's a positive going ramp. Okay, for the positive going ramp here, the output will become, okay, V out is equals to negative, okay, 10 volt over 5 millisecond. VC is 10 volt. How do you get 10 volt? Okay, the 10 volt here is getting by the value here. It's a positive going ramp from negative 5 to positive 5 volt. So the difference is 10 volt. Okay. So here VC is the difference of voltage when it is a positive going ramp. Okay, over 5 is 5 millisecond for the first ramp up, 10 volt. Okay, 10 volt over 5 millisecond for the first ramp up here. Okay, times with RF. RF is 2.2 kilo ohm times with the capacitor. Value is 0.01 microfarad. And the value is negative 4.4 volt. Okay, so this is V out when it is a positive going ramp. Okay, so what is the V out for the negative going ramp? Okay, now is the negative going ramp. Okay, we just note a little bit here. A negative going ramp, this is V out for positive going ramp. Okay, now we're going to find out for V out of a negative going ramp. Okay, it's simply the likewise of the positive going ramp, which is the value will become, because why is because it is the voltage here. Okay, VC will be negative. Okay, because it's a negative going ramp. Okay, simply like this, negative 10 volts over 5 millisecond times with the same value here. So you will get the answer as a positive 4.4 volt. Okay, so this is V out for the positive ramp, and this is V out, a positive 4.4 for the negative ramp. Okay, so now we are going to draw the output waveform. Okay, one more thing, the difference of the differentiator and integrator. Integrator kind of op-amp, okay, it converts the signal from a square waveform input into a triangular waveform. Okay, whereas for a differentiator op-amp, okay, it converts the triangular input waveform into a square waveform output. Okay, so let's say this is I think I need more space, so I'm going to use another paper. So now we are going to draw the relationship of input voltage and output voltage. Okay, so let's say this is for V input. Okay, it's given a triangular, oh my, I'm not drawing it using graph, so dia dah macam-macam. didn't have scale here. Okay, this is just some sketch, right? So this is the input waveform just now, as we can see here. Okay, here the question is the input waveform. It's a triangular, okay, and the minimum is -5 and the maximum peak is of +5. Okay, now we are going to draw the output waveform. Okay, just let it be like this, straight line. Okay, now this is the V out 0. Okay, we have find out just now. This is the V out, -4.4 for the positive going ramp and +4.4 for the negative going ramp. Alright, so what you can do here is from the here, okay, and here, this is positive going ramp, this is negative going ramp. So we see how the transition of the waveform, okay, how this kind of transition affected the output waveform. Okay, now for the positive going ramp, okay, start from means it will it will transit down, okay. For the positive, when it is a positive going ramp, okay, the output will become like this. So the maximum voltage is positive 4.4 volt and the minimum is negative 4.4 volt. Okay, so starting from here, okay, this is the waveform, the output waveform. For positive going ramp, it will go down until the negative maximum, okay, this point up to here, okay, and then when it is negative going ramp, it will switch back to a maximum positive voltage, okay, and then it's switch back, then it switch back, then it switch ramp up, so it switch up. Okay, sorry, you follow the, assume that it follows this grid, okay. So when it ramp down and it switch down back, right. So this is the output voltage, okay. You know, this is 5 microsecond and this is 10 microsecond is here, right? 10 microseconds, so you can label everything, okay, just like the input 5 microsecond, here is 10 microsecond, here is 15 microsecond, the time, here is time, right? And 20 microsecond. Okay, I think that's it for example 6.